and pick up on the PowerPoint. Okay. Let me go over a few of these announcements. I wanted to wait till Screencast-O-Matic was open so you would hear it. Mr. Gerasi is always looking for students who would be interested in being on the math team. They're doing the practicing now for next fall's competition. So if you are interested, it's a lot of fun. You'll learn a lot, but it'll be fun doing so. Now, just for your information, we have a training presentation Thursday afternoon, 2 to 3:45. So that's right in the middle of what's usually my office hours. So I'll probably be down the hall, way down the hall there, at the training for that. So if you're looking for me Thursday afternoon, don't come by at 2 to 3:45. Now, it may be that I won't go to it if the room is packed down full. I want somebody else to get the training. I'm not going to be here long enough for it, but I do want to have a good showing there. Now, here's something else. I haven't started getting many grades in. I've got one quiz and a few papers. Everybody's doing well so far, but it's usually the people who haven't turned things in that, might be struggling. So it's the ones who have turned in are usually pretty on top of things. On this campus, Vassar campus, in this building, there are two potential tutoring sources. One is just about 2/3 of the way down the hall here. In fact, when you look down that long hallway, you'll see 3 exit signs. The first one goes down toward the, say, financial aid area, that kind of stuff. The second one goes toward the cafeteria. At that second exit, don't go down the stairs. Take a right there. That's room 202. That's the SSS, Student Support Services Tutorial Lab. Ms. Hollins is the coordinator for it, but I know that Ms. Martin, who teaches developmental math here, but she's great in every level of math. She has hours in there every week, so she is really good. There are peer tutors in there who are really good, so take advantage of that if you need it. And Gavin, got it. Okay. And again, Kirkland. I'm sorry.
Kelsey.
Drake. Okay. Kelsey. Okay. I can't hear well. Okay. All right. Anyone else come in since I called roll? So that's one location for tutoring. Great tutors there, available just about anytime during normal working hours, and they can probably set up late working hours too. All right. In addition to that, that stairwell I'm talking about, the second one that goes toward the cafeteria, if you go down that, but don't go toward the cafeteria, go down completely to the first floor underneath this floor, and as soon as you come out of the stairwell, make a sharp right around the corner, and that's the Space Center. They have tutors in there. Now, they sent this over, and it's only 2 days, Monday and Tuesday, they have tutors there. From 12 to 4, Mr. Tariq Lake is there for developmental math. Okay, I know this isn't developmental, but he was in my calculus class, so I think he can tutor more than developmental. Okay, but that's from 12 to 4 on Mondays. But on Tuesdays, from 10:30 to 2:30, Mr. Etheridge Means, who is a professional, he was an adjunct instructor for us, and now he's doing tutoring. He tutors all math levels. So that's your best shot. Tuesday, 10:30 to 2:30, Mr. Means is down there, will be down there. You don't have to set it up for him. He's there. And Monday, 12 to 4, Tariq Lake is there. He's a student, but he should know the math pretty well. He better. Okay. Now, oh, there it is. Some of you are Birmingham students as well, right? Okay. On the Birmingham campus, there's 3 potential tutoring sites. Now, the first one probably won't be any good for y'all. It may be, I don't know. It's the SSS Tutoring Lab, and that's in the C building, the science building, the end toward the B building. As soon as you go in, right past the machines, the snack machines there, into the C building, first door on the right is the SSS tutoring lab. If you're coming from the library building, though, and the C building is really short, I think it's something like C104 or something like that, maybe 106, something like that. That's the SSS tutoring. That's probably mostly for developmental tutoring, but you can check it out. If you go on into the B building and make that bend around the curve there, the first door on the right, when you take a right, is B118. That's the STEM lab. I don't know what hours they have tutoring there, but they do have tutoring various times during the week. Okay? Then if you go over to the Leon Kennedy Center, the student center, where the cafeteria is, go up to the second floor where the bookstore is. Well, kind of across from the bookstore is the space lab there. And these are the hours for tutoring there. I'll give you only upper level math. Monday, 10:30 to 2, Mr. Means will be there. Okay, he also tutors chemistry if you need that. Tuesday, Tariq is there 1:30 to 5, but he is labeled for developmental, but I bet you can help with this too. And that's it. 2 to 3:15 is by appointment only, but it says developmental, so I don't know if that works there. Wednesday, 10:30 to 2, Mr. Means, all levels of math. And Tariq Lake is there 1:30 to 5 for developmental math, but I think he can do the other. And then 11 to 12:30, they say again, developmental math by appointment only. I don't know really what that means. Okay, on Thursday, 10:30 to 2, Mr. Means. Tariq's there 1:30 to 5. And on Friday, Tariq is there 1:30 to 4, but Mr. Means is there 10:30 to 12:30. So lots of opportunities on the Birmingham campus. Okay, those are all the Space Center hours. Now, I think some of you, probably most of you, hopefully all of you are aware, this is homecoming week, right? Okay. Now, last night there was a basketball game, right? Boston versus Sneed State. How'd we do? Ah, way to go. Okay. And other things coming up. Tuesday, today, scholarship and transfer information. Miss Nicole Evans and Quiana Stevens, I can't read this, at 10 o'clock are here in the faculty staff dining room. That's near the cafeteria, okay, on this campus. And Mr. Dorian Walloon is on the Space Center in the Leon Kennedy Center building, the second floor, also at 10 o'clock. This evening, there is a comedy show. Lawrence Jackson, I don't know what, FT, and Miss Maddie J, featuring, I guess it is, Miss Maddie J, will be at 4 p.m. in the A.G. Gaston Auditorium on the Birmingham East Campus, okay? Wednesday, Name That Tune here in our cafeteria at 12 o'clock noon. And More Than History, the speaker, Mr. Eric Guster, is at 12 noon in the ACAT Auditorium on the Birmingham West Campus. And I'll tell you about Thursday on Thursday. Okay? Activities all week long.
When's the comedy thing?
The comedy thing, I think, is tonight, isn't it? 4 p.m. It seems like it's tonight. They have it under Tuesday. Okay, and that's at the A.G. Gaston Auditorium on the East Campus, near the dormitory, okay, housing. Okay, good deal. Boy, that was more announcements than I wanted, okay? But glad to make them. Okay, where we're picking up today is example 2, top of page 77. First, are there any questions? A few people needed quiz. Yes?
What's the test?
Huh?
What's the test?
When we finish 1.9. We're in 1.8, so it's not far. Okay. Several people earlier were asking for copies of the quiz. Does everybody have a copy of the quiz? Okay. All right. And I call everybody coming in, right? No one's here that I missed, right? Okay. So let's do, if there are no further questions, example 2. And by the way, I can't get the pen to activate. There we go. By the way, anytime I give you a quiz or a test, you certainly can ask me for clarification. What do you mean by this? But I will not work a quiz or test questions in class. Obviously, that's what you're getting graded on. But I'll work anything from the text. So if you're having trouble with a quiz question, find one like it in the text. Either a homework exercise or example if you need that done again, and I'll be glad to do any of those. So, no questions. All right. Example 2. All right. Finding the difference of two functions. Given that f of x is equal to 2x plus 1, is that the same as we have? Yes, it is. So I'm not going to write those again. Okay? Okay? Same functions we have above here that we used in example 1. Okay? There's your f, there's your g. Okay? It says find f minus g of x. First, by definition, what is f minus g of x? Anyone know? Yeah, what's the rule for it? The difference, it sounds so redundant. This is a difference function. It's a new function. The difference function. The difference of two functions, the difference between two functions is the difference between the functions. Okay? So f minus g of x is the same as f of x. Help me. What does it look like it would be? Minus g of x. So all you do is plug them in. What is your f of x? 2x plus 1. Now here where you have to be a little more careful than you did with the sum of two functions. When you have a minus sign, be certain that you put g of x in parentheses. So what would you put there? X squared plus 2x minus 1. Okay? First thing you do then is clear the parentheses. Distribute that minus sign across the parentheses. So that gives you 2x plus 1. That doesn't change. What's next? Minus x squared minus 2x plus 1. And now what do you do? Not yet. Combine like terms. And what does that give you? A little louder? A little louder, I can't hear. Negative x squared plus 2, that's absolutely correct. Because your 2x and minus 2x add to 0. The two ones add to 2, and the minus x squared is by itself. So you can write that as 2 minus x squared, or negative x squared plus 2. All right? That was the first part of example 2. And if you look in the book, that's exactly what they got. Okay? The second part of the question says, then evaluate the difference when x is equal to 2. So what would that mean you do? F minus g, that's your difference function, but now you're going to evaluate at x equal 2. So what do we do here? Plug it in, plug it in. And how does that go? Did I hear someone whisper negative? Negative 2x squared plus 2. Now the big question is, what does that result in? Say again? Totally. Absolutely. Here we have the situation where we have a subtraction or a negation and a square. And unless there's a parenthesis around the negative 2, you do the exponent before you do the negation. So it's a negative 4 plus 2. And that comes out being negative 2. Negative 4 plus 2 equals negative 2. Got it? Okay. Now remember, every one of these examples has a checkpoint after it. And those checkpoints have audio-video solutions at larsonprecalculus.com. So please, as soon as you finish class, especially if any of these are a little fuzzy to you, do those. Do those checkpoints, because you can go right to the website and get help with it if you can't remember how we did it. All right, any questions on that? Pretty simple, right? Okay, let's now do example 3. Okay? And this time we have different functions. Okay? Example 3, your f of x is equal to x squared. And your g of x is equal to x minus 3. Okay? And what they ask us to find now is f g of x, the product function of those two functions. And what by definition is that? Is the product of the two functions, exactly. So that would be what? I'll write it down, f of x times g of x. And what is your f of x? X squared. And your g of x? X minus 3. And when you do the product, what do you get? X to the third minus 3x squared. Done. I wish I could make it harder. I haven't figured out a way to do so. Okay? So it's pretty simple stuff, right? Then evaluate that product when x is equal to 4. And that would be the product function when x equals 4. And what would that be? You can write it out if you want to. Say again. 4 cubed everywhere you see an x, put a 4 in. What's next? Minus. Feel like a dentist up here, okay. 3 times 4 squared, okay. You can put it inside or outside, I don't care. What's 4 cubed? Anyone know? Say again? Okay, 4 times 4 is 16. 16 times 4 is 64. Okay, that would be 64 minus 3 times 16. That would be 64 minus, anyone know what 3 times 16 is? 48. I thought I heard, right? And what does that give us? Difference of those is? Oh boy, bring out the black boxes, okay? 16, got it, okay? And by the way, I should have done this on the last one too. I'll do it on this one. You could have also done it this way. If you weren't interested in what the product function was, which is what we did here, all you're interested in is the product at 4, you could have put 4 in here, which is, plugging a 4 in there would be 16. Plugging a 4 in here would be 1. And 1 times 16 is? 16. That would have been a lot easier, wouldn't it? And that's the deal here. You can either do the product function, or you can do the function of the product of the functions. Whichever is easier. And I go for easy, okay? So, because I'm fairly lazy, okay? So there we've got 16. All right. Any questions on that? All right. Let's move on to example 4. Now here we have two things to do. Here are your functions. F of x is equal to the square root of x, and g of x is equal to the square root of 4 minus x squared. They would have to, on the more complicated operation, division, give you really complicated functions, right? Pile it on, why not, okay? So, usually when I have this kind of situation, the previous ones, all three of the first examples, they only gave you polynomial functions. And what's true about polynomial functions? What's their domain? All real numbers, okay? These are not polynomial functions. So it's not a bad idea here to identify the domains. So what's your domain of f of x? Domain of f. What has to be true? When you see the radical sign. Now, if it doesn't have an index, what does that mean? Square root. Okay? All square roots is the truth. If it does have an index, if that's an even index, it's going to be true of that too. What is this that's going to be true? Say again? Yes. What's inside the house, inside the radical, has to be positive. So how do we write that mathematically? I'll start at x. Okay. All right. We can do it with brackets if you want to. I don't need the x if we're using a bracket. Okay. So tell me what to do with the bracket. Bracket. CJ is here, and so is Tadarius. There's CJ. And there's Tadarius. Okay. Anyone else come in since I called roll? Have we gotten it? Yeah, I thought you had. Okay. It's Jayla. Yeah, right. I looked over to see. Anyone else come in since I called roll? Okay. Okay, you gave me a bracket there. Left me hanging. Huh? What you put in the bracket? What's the first possible value that x can take on? 0. And it can take 0. So that's why we use a bracket. And how far can it go? Infinity. And what do we usually put after or near an infinity? Parentheses. Very good. All right. How about the g function here? What do we know must be true? Now this time, let's not quite go to bracket yet, or to interval notation yet. We have to do some figuring on that. That was pretty easy. X has to be greater than or equal to 0. It's non-negative. Okay, that's the way to say that. Here's how you write it. The g, what can you say? It's pretty easy to say. Whatever is under the house, which is 4 minus x squared, has to be positive or non-negative. Okay, so we'll write that down. 4 minus x squared. How do I write that mathematically? I don't want to spell out the words. Those are too hard. I like symbols. What must be true about 4 minus x squared? If it can't be negative, that means it has to be, okay, very good, or non-negative. How do I write that mathematically? What symbol will tell me something? especially with regard to a number. Okay, think about this. Nothing down here will work for it, right? What's the first thing that will? 0, and then it's got to be to infinity. So that everything to the right side of 0, including 0. So how do you write that mathematically? All those numbers are greater than or equal to 0. Okay, that's how we write it. Greater than or equal to 0. Okay, now the reason I did that is because we have to solve this inequality. How do we do that? Get x by itself. Isolate the x. Okay, so what would be your first step to do so? Subtract 4 from both sides is certainly a legal move in most states. So let's do that. And what do we have there? Negative x squared greater than or equal to negative 4. Now what do we need to do? I really don't care about negative x squared. I want to know what x is. Okay, multiply or divide by negative 1. Okay, and what will that give us? X squared. This will become a 4. What's my sign in between? Less than or equal to. Okay, remembering this. Anytime you add or subtract anything to a directional inequality, okay?
You got to change the direction of the sign.
Yeah, if you add or subtract anything to it, you don't change your thing. If you multiply or divide a positive number by it, you don't change your thing. It's only if you multiply or divide by a negative number, then you have to flip the direction of the inequality. So that's why it flipped that way. So now we have to think about what values of x, when you square them, are always less than or equal to 4. 2 certainly. So would you say 2 is less than, or x is less than or equal to 2? Certainly seems like that would work on the surface until you think about it. Okay, give me an x less than 2. 1. That's certainly when you square it. That will work. When you square it, 1 is less than 4. Okay, give me another number less than 2. 0. When you square 0, it's less than 4. Yes, we feel pretty good about it. Give me another number less than 2. Negative 2. Negative 2 squared is? No, it's positive 4. Negative 2 squared is positive 4. So that's equal to 4. Say again? Okay. Give me another one less than 2. Okay, that will work because 1 will be less than 4. Got it? Give me another one less than 2. Say again? We already did negative 2. Is that what you said?
Negative 6.
Negative 6. Okay? If we do negative 6 squared is? It turns positive. And it's way greater than 4. So we can't do every number less than 2. Where do we?
We stop it.
From negative 2 to positive 2. That's exactly it. So the x has to be between negative 2 and positive 2. Now, how could we write that in our interval notation? Bracket. Negative 2. Comma. 2. Bracket. Excellent. You got it. Okay. Pulling teeth again. All right. Here we go. Now what we're going to do is combine these functions algebraically. And we're going to combine them 2 different ways. But when we're combining algebraically, adding, subtracting, multiplying, or dividing, we have to make sure we're in this domain and in that domain. So what does that limit us to? negative 2 here is not in that domain, is it? No. So we can't have negative 2. Where do we begin? Second? Okay. You mean that's all we got in it is 2?
You got 0.
You got 0. So you can start at 0 and only go to 2. That's all, folks. You can't go all the way to infinity because this one stops at 2. You can't go to 0 because, to negative 2 here because that one stops at 0. Okay? So you're stuck between 0 and 2. Okay? Do you see that? I don't mean stuck there. That's the shared domain. So your shared domain here for these two functions is 0 to 2. That's all, folks. Okay. We haven't even started the problem yet. We just have determined the domains, which is part of the problem. So the first thing to ask is f of g of x. And how do you think that might be defined? Pretty much like you would expect, I think. F a quotient function is the quotient of the two functions. F of x divided by g of x. That's all, okay? So what do we plug in? What's your f of x? Square root of x over the square root of 4 minus x squared. There it is. That's it. Now, if this were multiplying or adding or subtracting, this would be its domain, right? Nope, not that one. That would be the domain, okay? Because it's a shared domain. But what else do we have to concern ourselves with if we're dividing? What can you never divide by? 0. What is going to make this 0? We hit them earlier. Okay, when x squared is equal to 4, which is when x is equal to 2. Okay, got it. And the 10 o'clock scholars here. No, I'm sorry, Kanisha's here. Okay. Well, I know you're in here. There you are. Okay. All right. So, in this case, you can't go all the way to 2. Because if you put 2 down here, you get 0. You can't divide by 0. So your domain for this function is, you can't put 0 there. Okay. 0 works in numerator and denominator. So your domain is from 0 to 2. But not counting 2. You see? Because if you use 2, you would get a 0 in the denominator. So that would have been the domain if you added, subtracted, or multiplied the two functions together. That's the shared domain. When you divide, though, you also have to consider what would make the denominator 0. Because you see, with your functions up here, 0 is fine under a square root if it's in the numerator. If it's in the denominator, the 0 is not here. So you have to exclude the 2 there. Okay? Make sense? Second part of this problem, well, what is g divided by f of x? And how would that be defined? G of x divided by f of x. And what's your g of x? Square root of 4 minus x squared. And what's your f of x? Square root of x. Okay? And that would be perfectly fine. And, of course, the shared domain is that. Is that also the domain for that? Or what do you have to exclude? Second? Yeah, we already excluded those here, right? Yeah. We excluded them here. We included a few here, but we then excluded here. But what else do we have? The fact that we're dividing. What's in the denominator? The square root of x. And What can we not have there? 0. You can take the square root of 0 if it's in the numerator, but you can't take the square root of 0. You can take it, but you can't divide by 0 if it's in the denominator. So what do we have to exclude here? The 0 one. 2 is fine there. No problem having a 0 in the numerator, and having a 2 in the denominator, square root of 2, no problem there either. But on this one, the domain is open parentheses 0 to 2. Bracket the 2, that's fine. Okay? So your domain, your shared domain is this one. When you put that g in the denominator, you have to exclude the place where the denominator would be 0. And when you put the f in the denominator, you have to exclude the place where the f would be 0. So that's why it changes the domain in those two issues. Does that make sense? Now, I'm not sure. Yeah, they did go into that as well. Okay? And they got the same answers. And what they didn't ask us for is evaluating at any one place. Now, if that was a little challenging, please do the checkpoints as soon as you get out of class and hear his audio-video solution. It may clear it up some. Mine's mucky, right? Murky? Something, okay. Any questions? Okay, now I think we're ready, if there's no questions, to move to composition of functions. Now, adding, subtracting, multiplying, dividing, we're kind of used to those, right? We just probably weren't used to doing them with functions. And what's more, having to then deal with the domains of the functions, okay? That was a little new. But we could do adding and subtracting and multiplying and dividing. Okay, and guess what, folks? You're going to see some of these on the test, okay? And I am shocked every time we do it how wacko some of the answers could become. I don't know. It's pretty simple stuff when we were doing it. So please pay attention to that, okay? But the composition of function, this is a new concept here for us, or at least I think it is. Most of the time we haven't hit this before. Another way of combining two functions is to form what we call the composition of one with the other. So here's an example, not one close to what we've had before, but a little bit different. Here's f of x equal x squared. Now we sometimes call that the squaring function. Whatever's inside here, you square it. Okay? G of x, on the other hand, is x plus 1. You might call that an addition function. You just add 1 to whatever's in here. That gives you the g function. Just adding to whatever you input, add 1 to it, you get the output. So, what in the world do we mean by the composition of f with g? Well, here's what we mean. Is f not operating on x anymore, but operating on g of x? Okay? Well, how do we do that then? Well, we simply, instead of g of x, put what g of x is. So it's f operating on x plus 1. But what is the f function? What does it do? It squares what's inside the parentheses, right? And what's inside the parentheses now? X plus 1. So you do x plus 1 and square it. That's f composed with g, the composition of f with g. Now you could go on and multiply those out if you wanted to. Does anyone remember what that turns out to be? You don't have to do this. That's perfectly fine to leave it in that form, but I find people sometimes forget what f plus 1 squared is. What would that be? X squared. A little louder. Understood a plus 1. Is that it? It's not. What have we forgotten? Okay. Here's, say again? Not 1x. 2x plus 2x. Okay? Say again? Forgot what? Yeah, they forgot to do the cross terms. So if you don't remember the rule there, and the rule is square the first term, twice the product of the two terms, and square the last term. That's the rule. If you don't remember the rule or don't like rules, okay, you can write down what x plus 1 squared is. X plus 1 squared, what does it mean to square something? multiply it by itself. X plus 1 times x plus 1. And how do we multiply two binomials? I got the hiccup, sorry. FOIL them, okay? First you get x squared, then you get outer is plus x, inner is plus x, and last is plus 1. And that gives you x squared plus 2x plus 1. That's why you double the product, okay? Same thing you get. So if you don't remember that, that's what it is. Now, you didn't need that for this thing. I'm just reminding you because a lot of people leave off that middle term and get something wrong there, okay? So every chance I have. Now, that composition can be denoted this way. And it seemed like it's pretty appropriate to me because sometimes it looks a little foggy, doesn't it? That's not what it means. It's the composition F composed with G. F composed with G. That's what the little circle in the middle is composed with. And the easiest way for me to remember, think of this as an of. F composed with G is the same as F of G. So put the G in the parentheses, just like F of X, but put G in there. F of G. And that's the definition, which we're going to have right here. The composition of the function F with the function G is F composed with G of X would be, just change this around to F of G of X. Okay? The domain of that, now this is where it gets a little tricky here. The domain of the composition is the domain of G to begin with, because that's what's inside, right? You have to have things that are functions of G, that are legitimate values to plug into G. But also then, you have to have things that are, your output for G has to be legitimate things for you to put as input for X. So you sort of have two steps for the domain. First, it has to be in the domain of G, and then the range of G has to be within the domain of F. If it's not, you have to exclude those values, okay? So the domain of F of G is a set of all X's in the domain of G. That's where you start, since that G is in the domain, the G of X, the output of that is in the domain of F. So here's how they do it in their mapping notation. You start with some X here, and G is what's operating on the X. So all the X's have to be in the domain of G. If G was a square root function, you couldn't have any negative X's here, because you can't take the square root of negative X. So that would be the requirement here. Well, that gives you an output function over here, and that output function, G, then that is where you pull your F's from, okay? So all your output from G has to be in the domain of F. The range of G has to be in the domain of F. And for instance, if this was also a square root function, then all the output here, because the square root is always positive, okay, if it's just square root of X, that would be a positive value. That would usually work here unless, there was something weird going on. So you have to also check first that the X is in the domain of G, and then that the range of G is in the domain of F. Okay? And skipping this step, that's the F of G. I know that's a little blah, 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 but make sense? No. Okay. I think when we see some, they probably will make more. Most of the time you're dealing with polynomial functions, no sweat, because everything is good there. All right, and these two are like that. So given that F of X is X plus 2, let me make sure they haven't skipped one here. No, they haven't, okay? And G of X is 4 minus X squared, okay? Find the following. What is F of G of X, or the composition of F with G of X? You tell me. First, what does that mean? What's the definition of that? F of G of X. Two parentheses there. That's how I always start it when I'm doing these compositions. Write down what it means. That's what we did in the others. F divided by g of x is f of x divided by g of x. So yeah, same thing. Write down what it means. Now, what do we plug in where? Start at the inside and work your way out. So f we're going to leave alone for now. Do we know what g of x is? 4 minus x squared. So put 4 minus x squared. Okay? You just plug in the g of x where you saw g of x. Okay? Plug it in, plug it in. Now, what does your f function say to do? Up here. What does the f function say to do? You take what's in the parentheses, x, and add 2 to it. Well, what's in your parentheses down here? 4 minus x squared. So you write that down. 4 minus x squared. And then you do what with it? Add 2 to it. That's it. So what does that give you? Okay, you can write it that way. Negative x squared plus 6. Or you could write it as 6 minus x squared. Either one are perfectly good answers. On WebAssign, only one of them would be a good answer. You know, they only let you choose one, even though they're both correct. All right, now we're going to turn that around and do what g of f is. The composition of g with f. What by definition would that be? A little louder. G of f of x. You got it. Okay? And what do we plug in first? Your f. And what's your f? X plus 2, right? And then what does the g function do? What does the g function do? Okay. What does the g function do? It starts with 4, so let's start with 4. And then it does what? Subtracts what? What's in the parentheses squared. And what's in your parentheses here? X plus 2, and then you square it. 4 minus x plus 2 squared. Got it? Now, what do you do next? What do you do first? Please excuse my dear Aunt Sally, or Sue, or whoever she is, whatever she did. Say again? Okay, you subtract, and now we do our squaring. You always do exponents before you do subtraction. Excuse before Sally, Sue, whatever her name is. Okay, so what does this become? X squared plus 4 what? Is that right? Did I hear that again? I didn't think I did. There is a plus 4 there, but what goes in between? Plus 4x, just 4x. Twice the product of the two. The product of those two is 2x, double that, you get 4x. There you have it. Now do your subtraction. And what do you get now? In other words, distribute the minus sign across the parentheses. 4 minus x squared minus 4x minus 4. And now what? Combine like terms, and what happens? Minus x squared minus 4x. You lost the 4's here. It's called 4 minus 4 is 0. Uh-oh. F of g of x is not the same as g of f of x. Notice that. F of x plus g of x is going to be the same as g of x plus f of x, right? That's fine. Subtraction won't work that way. Multiplication will work that way. Division won't work that way. Composition won't work that way. So we say the composition of two functions is generally not commutative. You can't go either way. Okay? We'll get to that later. Let's now do what they ask here. What is G composed of F of minus 2? And there's two ways you can do this. How would you choose to do it? Where? Okay, you're going to do G of F of minus 2, and that would be G of, what's F of minus 2? F of minus 2. I'm going to clear this other thing out of the way because it's, that would be 0, you're right. It would be minus 2 plus 2, that would be 0. So now you do G of 0, and what would that be? Say again? I don't think so. The G function? Yes, it's 4. You start with a 4 and subtract 0 squared. Okay? That's one way you could do it. The other way you could do it, since you had already done all this work to get what G of F of X is, we already knew that G composed with F of X was minus X squared minus 4X, right? So G composed with F of negative 2 would be a negative 2 squared minus 4 times a negative 2. I like the other way better. Okay, what would this give us? Say again? I don't think so. Well, it would ultimately, but let's do the steps. It'd be a minus, what's negative 2 squared? 4. This would be a plus 8, and sure enough, that gives you 4. So it does work either way. That's a lot easier to plug it in that way than this way. It's not always. Sometimes this way will be much easier than plugging in fairly complicated functions. Okay? But we see that that works the same way. Okay? Any questions on that? Now that's how we did it. Let's see how they did it. Okay, the A part here, the composition of F with G is as follows. You start with the definition. The composition of F with G of X is F of G of X. Okay? And then just plug in what G of X is. Same way we did. That gives us F of 4 minus X squared. Okay? Well, what is that? That's taking the F function that takes whatever's inside the parentheses and adds 2 to it. That gives you 4 minus X squared plus 2, right? And when you clear the parentheses, that gives you 6 minus X. Oh, nope, they did it the same way y'all did. Minus X squared plus 6. I don't know why. I would have written it 6 minus X squared. Both ways are right, okay? So there's the A part. Now let's do it the B part. G composed with F of X would be G of F of X. I think of this as the of here. G of F of X, okay? So that takes the G, hold off on that, and just plug in the F of X. That's G of X plus 2. What does the G function do? Starts with the number 4 and subtracts from that what's in parentheses squared. So that would be 4 minus what's in the parentheses, X plus 2, squared. Okay? And then they did it right, okay? 4 minus X squared minus plus 4X plus 4. Clear the parentheses or distribute that through, and you get minus X squared minus 4X, because the plus or minus 4 is with 0. Notice in this case, and let me also say this, in most cases, the composition of F with X, F with G of X, is not the same as the composition of G of F. G with F of X. Most of the time. We will run into, very soon, circumstances where those are equal. When they are, those are very special functions. And we'll see what that means to be those special functions later. But most cases, they're not. The compositions are not commuted. Okay? Now, using the result of Part B, then, they wrote the following, and they did it the second way we did. They didn't do it with the composition. They just took the function we had, minus x squared minus 4x, plugged in the minus 2 for the x. That's a minus 2 squared, minus 4 times minus 2. Well, that's a negative. A negative 2 squared is 4, so negative 4, and minus times minus is plus 8. And that added to be 4. And when we did it the other way, it came out 4 as well. It's better. Okay? Any questions on that? All right. Now, they're going to talk about it a little bit. In example 5, you form the composition of two given functions. In calculus, it is also important. Okay, this is jumping a new rabbit here. Okay, so before we go here, let me say this about example 5. That was a new kind of thing to do. That checkpoint, I think, is very, very important to do. Okay? Now, you can also do compositions with tables. And you just have to keep in mind you're doing f of g of x, or g of f of x, or whatever you're doing. You get the value, the output value of one, and feed it into the input of the next one. Okay. All right. Now, before we jump here, okay, let's go up and do example 6. Okay. They left off 6 from the slideshow. So let's do it in class. All right. Find the domain of f, I can't write, f composed with g of x. Okay? Close that parenthesis. For these functions, f of x is equal to x squared minus 9. And g of x is equal to the square root of 9 minus x squared. Okay. Find the domain of the composition of those two functions. Well, where would we start? Where would we start? What's that? I can't. Okay. You mean right here? Yeah. I would say, let's start with our definition. What is f of g, the composition of f of g of x? What's that definition? F of g of x. When you do that, to me, the domain now shows that you've got to start with the g function. You've got to know what the domain of g is. Okay? What is the domain of g? That's what g is. What is its domain? What has to be true about g? When you see that radical, what comes to mind? Okay, you can't have a negative number. How do we express that mathematically? Second? Get rid of it. Okay, you don't have a problem then, huh? Say that again? Okay, what do you do? What's in there cannot be negative. Write that mathematically. 9 minus x squared has to be greater than or equal to 0. You got it. That's what you mean. Take whatever's in the radical, it's got to be greater than or equal to 0, meaning it's got to be positive. Now solve that inequality. How would you do that? Subtract 9 from both sides. That's a legal move. What do you get? Negative x squared is greater than or equal to negative 9. What's next? Okay, multiply with negative 1. What does the left-hand side become? Left-hand side. X squared. And the right-hand side becomes 9. What does your sign become? Less than or equal to, because you multiplied by a negative number. All right, now what does that tell you? We've seen something very similar before. Remember how that panned out? If x squared has to be less than or equal to 9, where is x? What does x have to be? Say again? I can't hear. Okay. What would x squared have to be? What's the first thing that would pop in your mind? Okay. What if that was x squared is equal to 9? What would that indicate? Okay. If x squared was equal to 9, what would x have to be? Say again? Yes, it could be plus 3 or it could be negative 3. Okay.
So that would be negative 9.
Say again?
That would be negative 9.
Both, no, they would be a negative 9. It would be 9. When you square 3, you get 9. When you square negative 3, you also get 9, right? So, now for the square of x to be less than or equal to 9, equal to 9 we know there's a 3 over here, there's a 3 over here. But for it to be less than, then the x has to be between minus 3 and 3. Because, see, a 0 would work, 1 would work, and 2 would work. We went through all that before. But a negative 4 wouldn't work. Because negative 4 squared would be 16. That's greater than 9. So you have to stay in between the minus 3 and plus 3. So how do we express that? Second? Bracket. Negative 3 to 3. Okay. Okay. There's your domain of G. You have to start there. So you know that the domain of this composite function has got to be between negative 3 and 3. Okay. Now, the next thing we look at is what's the output of this. The output of a square root is, and that's a principal square root, meaning positive square root. So this is going to be a positive number somewhere between 0 and 9, right? Because if the 0's in there, that gives you a 9. Plus 3 or minus 3 gives you a 0. So it's going to be a positive number. Well, guess what? F function is a polynomial function. It will take anything you want to throw at it. So it's perfectly happy with the range of that. So that is your domain for this function. Okay? And as you see in the book, it says the brackets between minus 3 and 3. There is a checkpoint there. I highly recommend you do the checkpoint. Okay. Now, I think we're out of time, so let me give you a few homework exercises. I know you wouldn't want to leave without those. We're almost through with the section, by the way. You can do number 3. This is using graphs to add and various things. Okay, then do any of the odds 5 through 11. All those odds are in calcchat.com, 11's at calcview.com. Do all your odds 13 to 23. All of those are at calcchat, only 13's at calcview. Do either 25 or 27, both are at calcchat, 25's at calcview. Do any of the odds 29 to 33. They're all at calcchat, but only 33's at calcview. Then do any of the odds 35 to 41. They're all at calcchat, 35's at calcview. Do 43. It's a calcchat. Do either 45 or 47. They're both at calcchat, but only 45's at calcview. Okay? And stop there. We will do the rest of those next time. Make sense? All right. Now, so far I'm feeling okay, but boy, this morning I was so low of energy. I think the Tuesday after a treatment is my worst day. So I'll try to hang around as long as I can today, but once I run out of steam, I'm probably going to head home. So, but I'll hang around as much as possible. I have one student from yesterday's class who's coming to make up a test. I hope she's going to do it shortly after 10:45 because I don't know how much longer I'll be here. But I'll be here for a while anyway. I've got another class coming up now. Good deal.